All right. Hi, guys. Okay, hopefully I am streaming now. Hey, this is Miss A coming at you on May 14th, 2020, day number who knows of our current quarantine. It is a very beautiful day outside here in New York. So I'm kind of loving that, looking out my window. My cats are loving looking at the birds in the tree. That's one very nice thing about my new apartment. There's a tree outside the window, and so like my cats can watch all the birds and everything, and they kind of love it. So today, I wanted to get into CodeHS lessons 1.6, 7, and 8. Three lessons might seem kind of ambitious for today, but they are actually very, very quick lessons. There's really not much to them. Hopefully, this will be kind of a breezy one. So, without further ado, let's get going. Again, like always, I really, really, really want to thank the makers of CodeHS. This, product has really saved my bacon when it comes to being a programming teacher. They really just kind of have everything in here that you need and to get going, to keep your class managed and everything. So really, thanks to them so much. All right, so we are going to start off looking at lesson 1.6. So the idea here is what they call top-down design and decomposition. And so those might seem like very, very, very big words and terms, but that is okay. So as I was really talking a lot about in Tuesday's video, functions are really there to help you like break up and contain your code. So it helps you to break down a big problem into a number of smaller ones. It helps you break down, it helps you sort of create a toolbox of different tools that you can use for like different parts of the program. And really like as in just day-to-day life, that kind of breaking down problems is always going to help to make them easier, or at least to help cut down on your anxiety about them. Because, right, to the computer, it doesn't matter too much. This is all really like, these are tools for you, the human programmer, to make better sense of what you're doing. This is kind of what they're referring to as top-down design. This idea of taking the big picture, breaking it up into parts that make sense, right? You don't just want to divide up a problem for the sake of dividing it up. Those divisions should actually mean something. Like each part should be something identifiable that has kind of nice, clear boundaries to it as much as possible. Right, you can think of doing these things in stages. I used an example in Tuesday's video where I had Karel, right, doing a turnaround function. So basically he can start by turning left, and then he can do 2 lefts in order to turn around, and then he can do 2 turnarounds in order to make a full flip, like a full 360-degree circle. And so that would be a case of sort of creating this middle level, the turnaround, that can like kind of more easily get you from the low level to the high level. There's lots of reasons why you might have these different layers of functions. It really comes down to the problem that you're trying to take on with your programming. So really, like, I think that is kind of, if there's a big idea I would like to get across in all of this, it's that, like, let the problem guide how this looks, okay? So here, they use the example of making a movie that you can, break down into different parts, right? Any kind of large organization, they're gonna break down things into different roles, have some kind of division, have, say, departments who handle different things, and then those departments will have little subparts to them. So this is like an idea, or at least like a way of thinking that isn't like totally unnatural to us as human beings, right? Like it's definitely something that is there kind of to help make things make sense for the computer, right? Everything needs to be nice and orderly for the computer to work at its best. But it's also like it's a way that we as humans think as well. So here they're using the example of this problem where they want Karel, or Karl, I guess, to go from one end of the screen to the other end of the screen. And like over here, he starts here, he ends up here. And, you know, I'm not much of a sports person, but, you know, I have watched the Olympics in my time. I have seen the hurdles, and I've never seen them kind of just like float above, you know, the hurdles, right? They don't just like jump and fly. What happens is you get sort of as close to the hurdle as you can without, you know, hitting it. Then you jump over it and you land and you keep going. You jump over the next hurdle and you keep going. You do not just straight up fly over it. That is funny enough, that's something my students very, very frequently would try to do. So this time, like, really think of this as kind of a real world example where he's actually like jumping and there's gravity. So he like jumps up and he has to come back down. So how can we break this problem into different parts? So that's going to be kind of the big thing that you're going to want to take on in this, right? So in terms of thinking about this example. So let's see how they did it. Okay. But as you know, we get to this, I do really want you to think about what this might look like in terms of how you break it down, right? The way I was just describing it, for instance, right? In order to jump, you have to move to the hurdle, then you have to jump over the hurdle. You could even break down that jumping, right? There's the jumping up and then there's the jumping down. So depending on how you wanted to do this, you could either do, say, two functions, move to target and, or sort of move to hurdle and jump hurdle, or you could do this in three, move to hurdle, jump up, come down. So depending on how you would want to do it, you can divide it up into sort of 2 or 3 different ways. Okay. And here we go. So if we take a look at, okay, so good. This is the fresh version. All right. So as you can kind of see here, he's gonna start by running to the hurdle. And let's see how this was defined. Run to hurdle is 3 moves in a row. That just so happens to be what it is here. So if we look at the first case here, it's 1, 2, 3 spaces, sort of 3 moves before the first hurdle. 1, 2, 3 spaces to the next hurdle. So run to hurdle be 3 moves. So he starts by running to the hurdle, then jumping over the hurdle. So what does jumping over the hurdle look like? So we start with turn left, move, turn right. So we can imagine he's turning up to face the sky. He moves. He turns right to face forward. Then he moves again. So he should be like right here right now. And then he moves to go down, and then turns left to face forward. So let's watch that in motion. So he starts by running to the hurdle. Now we call the jump hurdle function. He starts by turning left. He moves. He turns right. He moves. Or sort of to turn right, this is going to take 3 turns. He moves. And now he's going to turn right again. So 3 lefts. Then he's going to move again. And he's going to turn left. So it takes, you know, quite a few instructions to get him up and over that hurdle, but it's not the worst thing in the world. And now that he has that, he can do this as many times as he needs. So let's keep going in here. So he jumped. Now he's going to run to the hurdle again. Now he's going to go through his whole action of jumping the hurdle. And now there's a separate run to finish here because he has to move 4 times to complete versus the 3 times of run to hurdle. This is a place where you could do this in different ways. Like since we already have 3 moves as run to hurdle, we could put that in here. Have run to finish call run to hurdle, and let's see how it does. He does just fine. So we could do that. Or instead of run to finish, we could just call run to hurdle and then a final move. That's doable too, right? And we could totally even just take this one out. And this one should still work. So there's never going to be like just one and only one way that you have to do your functions. So, this is the general idea with top-down design, right? Break your problem into parts. So the next example is, so the exercise in this one is one called the 2 towers, and the 2 towers is going to be just that. You have to make 2 towers. And so the way I want you to approach this is to think of this in terms of like, what are, try to say this in a human way. Right, your start function should kind of already look like how you might describe this to people, or at least that's what we're aiming for. Run to hurdle, jump hurdle, run to hurdle, jump hurdle, run to finish, or again, run to hurdle. So right, the way that this reads is very much like you might be instructing someone in plain human language. So I'm going to want you to do the same thing for the 2 towers here. How can you break it down into its distinct actions? And again, when you go to make your functions for those distinct actions, you only want it to do one clear action. Turn right does 1 right turn. Doesn't do 2 right turns. 1 right turn. Jump hurdle, he jumps over 1 hurdle. He's not going to do both hurdles, right, with just this one function. If we need to use it twice, we can use it twice, like we're doing here in the start function in lines 2 and 4. So now let's check out lesson 7. So this is kind of going with, I guess if you could say there's a theme to today's lessons, it is this division between the human and the computer, and the way that programming is like a compromise between these 2 very radically different ways of thinking. So commenting is one of these things that is literally only there for humans. When you say a comment in programming, it's definitely not there for the computer to do. The computer will not run any of this. The computer will not notice any of this. It will automatically skip anything that looks like one of these comments, which is actually a very, very, very useful set of traits to have. So, style is this thing that people have. Again, just look at yours, truly very, very stylish. Style definitely means something important when it comes to that compromise between human brains and computer brains, though, in that humans are messy. Computers do not like messes. Computers really like things to be clean and clear. Humans, we say that we like things to be clean and clear, but that is actually very rarely the case. And at the very least, even if we do like things clean and clear, if we're presented with a mess, we can usually figure our way through it. A computer is just going to break, right? It does not confront unexpected messes in a good way. And so the computer, it wants things to be regular, and it wants things to be repeated, and it wants things to be consistent. And so one of the ways that like we do this for our human brains, because it is hard for a human brain, right? Again, we're messy. We can rush through things. A lot of times will ignore little details and we'll keep pressing through. Whereas the computer, like though it, there is no distinction between the details and the big picture. Everything is details to the computer. So, we have to keep track of that. And style is a really important part of that, because one thing that I like about this idea is that it plays to human beings' strengths as far as how we think. Human beings tend to be like, when we're evaluating mistakes, we're not doing it the way a computer would, where we look at every single thing one at a time by itself and say, is this correct? And go through a set of rules. We don't do that. We look at big pictures and we see if anything stands out to us, right? That's just how our brains work. Our brains pick things out of environments. And so what a human would do when, say, you are a teacher proofreading a paper, or, someone proofreading your code, is that typically what you're doing is you're just sort of looking at it with your eyes. You're taking in this picture and you're looking to see if anything is out of place. Like, oh, this sentence looks way too long. Let me see what they're doing with their punctuation. Or this thing looks really out of place here. Or this just doesn't sound right. Often when I proofread papers, literally what I'm doing is I'm just reading the paper to myself. And, I'm just listening to it and thinking, that sounds funny, or that doesn't sound funny. And we're just looking for anything that sticks out like that. So style plays to that kind of strength, because basically the idea is this: if we can create a consistent way that our code should look, then it's going to be really easy for us to just look at our code and see when it's not obeying those rules. In the way that, say, like, even if you can't tell that someone is really poorly dressed, tell someone why they're poorly dressed, you can still certainly tell that they are poorly dressed, like they're somehow violating fashion, even if you don't necessarily know, like, what specific thing it is that they're not doing right. So again, style can be kind of good that way. So comments are a really important part of style, in that, like, they can create kind of guideposts. They create notes to yourself, so that, like, if you're trying to follow along, you can. So comments are just that. They are comments. They are comments that are there for you. So you can tell yourself, like, this function is here to do this. This program is supposed to act like this. They can help you, say, like, when your code is a work in progress, you can be like, this is where this new feature should go, or like, put this function in later. And so you can kind of remember to come back and put something where that comment was. Another thing that you'll see, a very useful part of commenting that you'll probably see me do in these videos as we go forward, is actually using comments as a way to kind of temporarily take chunks of code out of your program. So if your program isn't doing what you wanted it to do, and you just want to look at one very specific thing about how the program is working, right, you can comment out all the other stuff. Or if one part of your program isn't working just yet, say you add a new feature in, and it's just not working, well, you can just comment out that new thing if it ends up breaking the program, right? So you can sort of temporarily take it back out. You can take it out. You can put it in. And the reason that works is because comments are not read by the computer. Comments are purely for human beings, purely for humans. So there's in JavaScript, there's two big ways that this goes. There is the multi-line comment, which is what you see up at the top here, /*, and then it ends with a */. So multi-line codes are basically anything between here, the opening, and here, the closing, gets commented or is a comment. So you have to remember to do both. You have to open it with the /*, and then you have to close it with the //. There's also single line comments, which only work on a single line. And you might be wondering, like, why is this super useful? Why do we need both types? There's something that is super, super, super duper handy about single line comments, and that is they can exist on the same line as other regular non-commented code. And I'll show you what that looks like when we get to the example. Precondition. Okay. So let's take a look at the example here. So here's Hurdle Karel again, and now they have commented it. Beautiful. Up here, we see a little introduction. This is very, very common to have some kind of comment at the top of your code that is just saying, like, this code was written by such and such. So for instance, here we could just be like, and like, I don't need to do what they're doing with these starting stars, but I do think it looks nice. So I'm going to go ahead and stick to it. So what we can say here is like this exercise made by CodeHS. Thanks, CodeHS. And you can see, like, just anything that I keep writing, and I can, do this as much as I want, anything that I write is still green. It's still a comment. And that's how a multi-line comment works. It has an opening /*, and it has a closing //. Oh my God, what happens if I take out the */ at the end? Well, basically, like, everything after it continues to be a comment until it sees this next */ for this next comment. So let's go ahead and put that back in. Here we see examples of single line comments. I don't know necessarily why they put program on this line, but I think it's to illustrate, like, with single line comments, if the single line comments end up occupying more than one line, you have to individually comment with the // every single line. If I take this out, this is no longer commented. Okay. And now I want to show you, like, the cool thing about single line comments, and we could do it like this. So say, let's do it for this function. So what I can do is I start at the end. So these can only go at the end of a line of code. So I could go out here. I can do // this makes him run. Cool. It still works, though. Like, CodeHS is complaining at me here. It processes this as an indentation error for some reason, but it's totally valid code and it will still work, right? It does not change anything about how this works. So I really like that. I do that all the time in my own code. Okay, so let's keep going. So last part of today's live stream, we are going to talk about Super Karel. So we've done a lot of things with Karel over the previous 7 lessons. Karel has learned to turn right. He has learned how to jump over hurdles. We have taught him many different things, right? He's a very, very good boy. And all of that learning has now made him Super Karel. So Super Karel is just Karel, but now he knows how to turn right and turn around. And he also knows a couple of other things. But really, that's it. That's all this lesson is. So let's take a look at the example that they provided. And again, this is just exactly the same as the example we just saw in lesson 1.7. The only difference now is there is no turn right function. If we look at, let me open this up in a new tab. If we look at the one from 1.7, there is a turn right function here at the bottom on line 61. Now, if we go back to 1.8, oh my God, where is it? He doesn't need it anymore. He's a smart cookie now. He has done his homework. He has diligently listened to his teacher. He has learned these functions, and now he is Super Karel. And I think they just do this at this point so that you don't have to worry about making quite so many low-level functions like turn right and turn around. Because from here on out, we're going to want to work on some more substantial, substantive kind of lessons. So these have been lessons 1.6, 1.7, and 1.8. Join me again next week on Tuesday. I believe that is going to be May 19th. And where we will be going over lesson 9 on for loops, which are amazing. They are fantastic. They are one of the most essential things in a programmer's tool belt. They're just lovely. I love them. So that's going to be a really great video. I doubt we'll have time to hit 2 lessons, but who knows? We'll see. So again, if you're in my classes, please, let me know by email, Google Classroom, Google Chat, Google Meet, however you want to get in contact with me. Let me know if you watch the videos, if you have any questions about your exercises. If you're not in my class, welcome. I don't know why you're watching these videos, but cool. Please leave a comment below. Hopefully it's a nice one. I will see you guys later.